Hello everyone, welcome. Welcome to another stream. Hey there, Elwood J. Finley and Gloria Sir. Welcome guys. How's it going? Last stream was finishing up on the temporary resources. So if you are familiar with the CPU side, when you have stuff like arena allocators or a linear allocator, essentially we're doing something like that but for GPU resources, but it is kind of it's kind of a heap allocator at the same time. So there's different memory lifetimes on the GPU now. Maybe I can do a bit of a drawing. So for a frame, I guess let's do this bit of a recap. For a frame, you might render to a texture, right? You do some rendering to it, and then that texture is going to be the input to another texture, right? And then you operate on that data and output another texture, yeah? Now this texture is not used for the rest of the frame, so this memory can be reused for another texture, right? After this operation has finished. So this is what's known as temporary resources. So the way we basically do this in terms of blocks of memory is we have an arena allocator effectively for each type of resource. So buffers and images each have their own arena allocator. So this is B for buffers, and this is I for images, because that's what Vulkan calls them. B call them textures if you want. And essentially we start off with a block of memory, and then we sub-allocate from it, right? And we keep sub-allocating whenever we say, hey, create a temporary resource. And then every frame this gets reset back to 0 again, right? So you could say this is a used region. Then and then we allocate a texture, there's another used region, right? And then you might allocate another texture, but it uses more memory than available, so we allocate another arena to fit that texture, and maybe a bit more depending on how big the texture is. And we still have these two free areas here. This is a free area, that's a free area, that's a free area, right? So we basically just keep doing this strategy. Then again, at the beginning of the frame, we'll essentially get rid of all the used areas and reset it to being unused. So the bookkeeping just resets to everything being free, but the memory arenas stay around. So we've got this sort of system written out last stream. We still need to test it and plug it into the temporary resource creation and reset it every frame, that sort of thing. So this is what we're working on. Well, this is what we're finishing up on today. And the reason why we're doing this is because it will allow us to, every frame, change the size of a texture, and that is very helpful when you want to resize the screen, for instance, which we do not have yet. So yeah, should be super sweet. Yeah, how you guys doing? Welcome. Right, so I believe, let me just plug my headphones in. There we go. Okay, and I guess I can give a bit of a recap on my encoder system. Basically, let me zoom in a bit. So I think it's getting pretty close to being done now. I've got a much smaller list left. I think my to-do list is this now here. If I'm just doing more of the advanced features now, so it's all tested out, saves out to text file formats, saves out to, and reads from them, can do upgrades, and what else can it do? And binary files as well. Actually no, I've got to test the binary file one. Wait, no, the binary one works because that's how the text. Yeah, the text one takes the binary file in. Yeah. But I still got to test out. Save and load of binary file. But yeah, actually saving it to disk and loading it to disk, I've not tested that out. But yeah, I've just got to do some more sort of advanced features and make sure I put if statements all in the right place. Some of the so if we see this sort of like testing code file which describes the data format, it's just a C file for describing data. But a feature that I want to have support is something like this, where we can say packed U32 times 3, so that's just a vector 3 of U32. And you can individually choose the packing of each of the components. So this would be quite powerful for GPU, so we can sort of pack vectors down with a different precision for every component. So that'll be super helpful for transforms because they get quite big. We can pack them down, hopefully, very well like this. And I've got to add the ability to sort of do this sort of packed type for a quaternion and pack it down into a smaller number of bits. That's something I want to be able to do. That'll pack it down into 9 bits or something. It's probably a bit too small, but that's the idea. So I'm working on these sort of advanced features now, but it's pretty close. It's definitely ready to start being used for the material stuff, which we'll get working on after the resizing work has been done. Yeah, it's pretty cool. It's coming together. Right, let's get started today on that resize. On the temporary resource allocator thing. So in GPU Vulkan, I went and made, last stream, right? I went and made this sort of like Vulkan memory allocator. And it's that sort of heap allocator, but when you run out of heaps, you just allocate another heap, right? And that whole heap is a free block. And it's a port of the BVH allocator, right? Rather than working on BVH nodes, it works on bytes. And aligns the bytes and stuff like this. But luckily, PassMe wrote a validate and test function. So the validate function will simply go over all the blocks, goes over every single block and just flips a bit. I call it the TikTok bit. And essentially there's one stored in the allocator as well. So we go over all the different linked lists effectively, and then we finally just go over all the blocks we've allocated, make sure that the TikTok bit is equal, and that will ensure that we don't lose a block. We haven't sort of lost a block. It's always in at least one of the linked lists, the free block list or something else. Yeah, free block or the unused linked list. And we just validate everything else as well. So that ensures that the whole system is valid. And then I've got a test function which basically goes over 4 times and then it generates 512 random indices and then swaps them 100 times randomly. Generates 512 indices and then goes over 100 times and swaps 100 random indices. And then we'll go over all those indices and basically allocate and deallocate if they're allocated or not randomly. So yeah, this is the test we're going to try out first before we hook it up, just to verify and make sure it all works and works before we plug it in proper and switch things over to using it. So what I want to do first is go into the internals Vulkan header. And actually, I think I want to move this above. Right, we've got to get our house in order a bit here. Hey there, Wajilla. How's it going? Welcome, welcome. How have you guys been? Hope the weekend's going well. Right, so I guess this is what's known as the, we'll call this the sort of like functions. These are the function load. This is the function loader, right? A lot of people use Vulk or whatever for some reason, but it literally is, you know, like 100 lines of, less than 100 lines of code, and you got yourself your own function loader. It's not rocket science. Let's just separate that out a bit. This is the resource backend structure, rightio. I guess I can call that resource. Now I want to put the memory allocator somewhere in between here, because this could just be called the Vulkan here. Working on deferred pipeline. Awesome. So is that like with a G buffer? Deferred rendering, right? Vulk used to be necessary before Vulkan lib became a DLL importer. DLL importer. I'm not sure what that means. So like, I know vulkan.lib or vulkan-1.lib, whatever it's called, right, had the it essentially has a loader in there, right? But the whole point of Vulk is that it is the loader, right? And it preloads everything and puts it into a structure, basically, right? Rather than making it some hash table lookup based on the device handle, like the loader will do, right? There's less indirection when you make a Vulkan call. Right, so the reason why I moved the allocator up here is because what I want to do is have one allocator, yeah? Let's stick in this memory stuff, because it's a memory thing. So this is going to be called memory allocator buffer, memory allocator image. So we're going to instantiate these and then we'll run the tests. So in VK, what was it called, backend init, is that what it's called? Yeah, GP backend init. So somewhere along here we do stuff with memory, I'm pretty sure. What was this creating? Oh, the printf buffers. All right. Yeah, I could. Thing is, I could share this with the static allocator as well. Yeah, what I might do, right, is actually have a few of them. So static buffer, static image. It might have a temp buffer, temp image, and we could switch it all over to this memory allocator system, and that should in theory help us save time when we boot up, maybe allocating less stuff and sharing the same Um, yeah, just showing the same heap might be quite good. So let's instantiate these. Alright, so what goes on here? So we create an instance, create a device. I think that's still very hard coded. Descriptors. Alright, here's where we search for the memory stuff. Find memory type indices. Right, so here I guess we'll instantiate the allocators. Init memory allocators. So here we'll just go a GPU Vulkan mem allocator init. Something like that. There we go. GPU Vulkan stack buffer. GPU Vulkan memory type buffer. So that's for a stack buffer. Image and stack images. Not sure how many of these we actually have, but there we go. Then we'll do it again, but for temp. Vulkan-1 instead is actually static lib is just a loader, yeah. Because what would happen previously is you would statically link to an old version of Vulkan. Yeah, definitely, that would. Yeah, see, this is why when I hear like the Zig language and that going, oh, you want to statically link against everything, even a GPU driver, it just sounds like they don't know like why that would be problematic. Hey Toggle. How you doing? Good to see you. How's the family going? Yeah, I'm doing good, man. Doing great. Just knee deep in Vulkan right now again. I postponed getting window resizing done for the longest time. So yeah, window resizing is something we're beginning to work on now. So I just need to work on a way to have textures of different sizes. So that's what we're working on right now, and then we can move on to actually resizing a window. But yeah, I made an OK Lab color picker recently. I think that's just been hidden. For crying out loud, what line is that? 47. Yeah, I made if you're familiar with OK Lab, it's an OK LCH color picker. So we can pick colors. I want to make a material editor so we can change, edit material properties of these things, and when we make models, select from those materials. So I need a fancy color picker. So I made this guy. It's quite cool. So I'm not good at picking colors, but I sure hope the person who is good at picking colors when they use this will be like, oh, this is great. But yeah, that's my hope. But yeah. So I hope that it is good. Better than HSV, I hope, for picking colors. I don't know. It means that it's perceptually, when you change the hue, perceptually the brightness stays the same. So things won't get brighter when you just change the hue, which I think should be quite beneficial. But yeah, how's the project going along, Toggle? Hey, Kraz, welcome, sir. I think it's the evil cousin of Rust, if we think about it. I imagine so. Family's covered in rust. How are things on your end? Yes. Yeah, things are going good. Yeah. My boy is nearly walking, but he's just not got the confidence yet. Yeah, it's a lot of fun. I had every Wednesday off for the past like month, but that's come to an end now. I went to a party as well at work last Friday, and yeah, drove back quite late, and it was tiring, but it was cool. It's great fun. Kind of like RGB color space. No. So OK Lab is no OKLCH. An OK Lab. Yeah, you should just look into it. Have a look into it, and you'll understand it. I think there's some YouTube videos on it as well if you wanna watch stuff about it. But yeah, I'll leave a link to this. And OKLCH is just the it broken down into hue and chroma like that. Yeah, we are closer to window resizing, that's for sure. Yeah, I cannot wait for the day. It'll start feeling like a real application. I remember when my kids took their first steps, pretty fantastic. Yes, it is. Like, it's so much fun. Yeah, it's so much fun. See them do stuff. Like, saw a picture of our boy, or a video of our boy when he was younger. Only like, he's only a year and 3 months at the moment. But yeah, his face was just so much different. It's just good just to look back at that. It's great. That's why it's good that we've got phones these days, just sort of record the crap out of them for our own pleasure later. Yeah, good times. Yeah, so I want to validate this, make sure it works. So let's just take like the buffer one, and let's like run that test function on it, on that pass Henry wrote. And let's just see if the computer still works. Hopefully the computer still works after this. And then we'll jump in the debugger and just see what it does. Maybe. Or maybe just put some print statements in. Because... Right, okay. Computer says no. Align must be a power of 2. Right. So I had to change the test because this one has alignment, whereas the code that I took it from was allocating elements of a BVH node. So now, yeah. Round up to the alignment of... Wait. Yeah, let's round up to a 2. No, it has to be a power of 2, doesn't it? Sorry, whoops. Right, so we just did random between and 8. And then we'll one shift left it, and that'll make it power of 2. Yeah. Alright, see how this goes. Crap. Block ID 1 is not allocated or in the free list or in the unused linked list, or is the free list or is in the free list multiple times. Right. So that TikTok bit was out of sync apparently. Let me drop in the debugger and see how long it took to get that. It seems like it was on the first one, which makes me seem like the TikTok bit wasn't initialized properly. Right, so if I break on GPU VK mem allocated test. So we go into here, we generate a bunch of random indices, and then we go over all those indices. And if the indice is allocated, we deallocate. If not, we allocate. So here's the first one, and it fails, right? So that leads, right. So we break, let's run there again. So what is the TikTok bit now? So it's expecting to go to, it's expecting it all to be 1. So we pick up a block now. What is that blocks? Validate TikTok bit is 0. Okay, so it seems like there is a legitimate problem here. Maybe. Let's check the code and make sure we instantiate those validate TikTok bits to the appropriate value. So when we allocate a block, I think it's called alloc block or block allocate. Yeah, so whenever we create a block, we always set it to whatever the TikTok bit is in the allocator. So we can then tell when we call validate whether or not all blocks have been visited. All right, so I think we legitimately found. All right, let's try that again. So in GPU VK memory allocator validate, let's see how far it takes to actually find one that's a problem. Right, seems like it goes over all these here. Yeah, so right, actually gets to this part of the code. Right, this validates that all of the blocks, validate all the blocks that bookkeep the memory that is physically contiguous. So it goes over all the heaps and goes to the block at the start of the heap and just linked lists all of the physically contiguous blocks, and ticks the toggles this TikTok bit. So that's if it is worthy of being in the free list. Or it is not worthy of being in the free list. We tick it. Right. Then we go over all the unused ones. These are ones which are not in the free list or not allocated, but we keep them around. And we grab it whenever we want a new free list item or a new allocated block. Then these are the actual free lists. And we go over all the free lists and then we tick. Right. Because if we didn't have this if statement, it would get double ticked. Yeah. Okay, so that's interesting. So if I get down to here, it's the first block that failed, right? Yeah, it was the first block. That's really weird. So the first block. So if I look at heap, yeah, that block ID is 1, right? But we go into here, and this is block 0. So that's the one that said it didn't get ticked. So it's right. Oh, let me turn off the big light. BRB. Right, so I think I have an idea of what's going on. Huh. So we're ticking all the ones which are... Oh, so this one... Wait, this block is free. Yes. So it should show up in the free list section. Okay. So I don't think we have many blocks. If we keep going, it will just... Yeah, this is... Wait, what did it just do in this round? It would have... Yes, it should have allocated something. Right. Okay, so this is the free list. It's got a bunch of buckets. Each bucket is represents a power of 2. So whenever you want to grab an allocation, you get your size, you find the nearest power of 2, and you go to the one up. And then you, in that free list, everything in that free list is guaranteed to fit the thing you're trying to allocate. Therefore, you can just return the first thing in the free list, remove it from the head of the free list and put the next one at the head of the free list and just return the allocation, basically. If it's not a perfect fit or whatever, you can sort of like trim the end off and put that back into the free list. So it makes it very much... The search is O1 complexity, right? You're just sort of... It's kind of... we're not visiting many blocks and comparing, but there is a bit of work to be done to patch the blocks and resize them, put them back in and stuff like that. And there is a bit of wastage when you do it this way. You'd always waste a bit of memory, but that's okay. Since we probably have larger allocations anyway, and not as many. Right, so this should have a... Right, so I don't think we put the block in the free list head and it maybe failed to allocate. That's my assumption. Let me put a breakpoint right about here. Give it a restart. So when we allocate, what's it doing? So it calculates the size. Goes over all the free... And then it can't find one, so it returns null. Alright, so I think we didn't set up... That sounds about right. So when we instantiate this memory allocator, we're making a... Oh yeah, but if there isn't enough, we should always allocate something new. Yeah. Where's my allocate new heaps code? Have I done that yet? Heap alloc. No, I haven't got... Okay, so that's something we're clearly missing. Right. Interesting. So I'm interested, what size did we allocate? Did we allocate just a min? Right, so we break GPU VK memory allocator in it. So we just take a look at one of these. What we'll find is when we allocate, we'll just do a minimum capacity. So it's that, right, it's like 128 megabytes. So the thing we tried to allocate was more than 128 megabytes, I think. So we go to alloc. Report the size. Size is no. Right, I should have found it. How many buckets we got? Bucket index for fine. Okay, something's a little bit off there. Okay. So first off, this needs to be instantiated to 0. Just in case this never runs. Then, right, so this gets the takes away the min, that's correct. Right, so what I want to do is just write print bucket. So we'll just write like insert into that free list head, hopefully. And then we want to be able to say search, or maybe it could be called find. So let's just run that and see what we get in the terminal. We're going to see a bunch of inserts, and the reason is because we've got 4 different allocations. Is that right? Yeah, 4 different allocators that we're instantiating. So they put into 10, and then we search from 7. Right, I'm interested. Why? So maybe we didn't actually put it in. Right, so let's put a breakpoint. In here. And just give that a look and see if it does actually put it in the bucket. So now your block ID will be 1 and it puts it directly onto the free list head. All right, good. So when does the allocate? Break GPEV gate. Memory allocator, allocate, continue. It's just doing all the other breakpoints. There we go. Cool, so we should get a 7, then we'll go around. Right, bucket index 8, 9. Oh. Is 10 outside? How bizarre. Right. Seems to me like there's some off by 1 error. So with power of 2 buckets. Right, I think we might have to do +1 here. So what's going on? Yes, you got a min and max, and that's inclusive. So basically from 64K, that's our minimum size bucket. Any piece of memory which is below 64K, we're just not going to care about it. I think we might make it a bit smaller, but we'll see. But then anything above, what is that? How many megabytes is that? Is it 256 meg or something like that? Right, 64 meg. Anything that's above a 64 megabyte allocation will always just go in the biggest bucket. So I think, right, so there's actually 11 slots, right? Interesting. Maybe we'll bring this down by That's 32k. That's 16k. Yeah. Let's just do something like that. Right, so that should fix the bug. Was basically insert and out of bounds on a C array here. So I was going out. Yeah, very bad. So we corrected that. Now, so we still have this other problem though, and that is that if we allocate anything and fail, we want to always allocate a new heap and then return that memory. So let's run the test and see how well this works. Right, block is the free list head, but has a previous free list ID for some reason. Great. Let's do after the first iteration. So we should be able to follow that. Let's just put a breakpoint in the allocation, because when we allocate, this is the thing that is going to obviously change the change it into the invalid state. So we can just search in here and find the answer. Yeah, so it goes up to 10 and then it grabs the block. And then it says that this block that we've grabbed from the free list is no longer free, and this is the one we're going to return. Oh, what is this? Oh, right, that wasn't in the validator. That was actually when we allocate it. Interesting. So I think then we're just not instantiating the memory properly. So when we instantiate the allocator and make the first heap and block, we zero the block. How bizarre. How bizarre. So it's pointing back. What is that block free list ID? Right, so its ID is 1. It's pointing back to itself and pointing next to itself. Very bizarre. So I think that if we go to instantiation, memory init, restart that. So we allocate a heap. So this allocates does one Vulkan memory allocation of 64 meg. So what's the blocks should be 0 here, right? It makes sense because we zeroed it. Yep. Then we set some things. So this is likely the function where it makes it the free list head. Right, puts it in there, all good. I can't see what's going on. So what I'm going to do is take do a watch point, right? So do the free list next ID. What we find out if you just print it is 0, as it should be. So if we put the watch point on, dereference, you gotta cast it. I wish I knew a better way to do this. Alright, and we hit continue. Right, that thing there did it. Alright, so for some reason when we instantiate it again, Wait, what would you say? Yeah, we instantiate a different... what do we do? Oh wait, no, sorry, this just broke in the allocator initialize. Oh no, it didn't. Oh, am I setting it as a free list head in 2 places? Did I... Shoot. So I set it as the free list head in 2 places. I set it here. Oh my days. Right, interesting. Right, so we allocate a new heap. Okay. So I wonder why we want to do this. I guess we'll remove that. Alright, let's give that a go. Alright, so apparently the test runs successfulully. It doesn't. And yeah, it just randomly allocates and deallocates a bunch of memory basically, and the validation runs fine. So we're still missing out, or sorry, we're still not solved the problem where if we allocate something that's too big, it's going to return null. So that one is here when we allocate. So we need to allocate a new heap with a required size that it is definitely big enough to store the allocation that we're looking for. And it's going to be put in as the free list head. So we could probably calculate the block. So I don't know what bucket it's in though. Yeah, I can reuse the bucket here like that. Right. That's what I do. So this is when we have failed to find something with a valid size. So we'll actually do the expensive operation of asking the driver to allocate some more memory. Alright, let's get a new heap with a required size of the requested allocation. Now we might round this up to the nearest minimum, a multiple of the nearest minimum. Oh yeah, what we'll do is we'll say pick the maximum between this size and the minimum heap size. Right. What's the minimum capacity of the heap? And then after that, we can get the block. So there'll be one block which covers the whole heap, and it'll be a free block. And that would have been added to the free list. So what we can do is get that block like so. What do I need? Oh no, there's like a size, isn't there? Oh no, I just call it heap size. So I don't need the block yet. Was it E64 heap size? Yeah. So I don't need to get the block. The code below will get the block. So now what we need to do is get the bucket index. Given the heap size, what was it inserted into what bucket? So we'll do that there. And then there'll be a block free list ID. So that's 1 plus the index. So heap start index plus 1. That would get us our the block ID for that new block that covers the whole heap. So now the rest of the code will be able to run as normal. So we'll get the block, and then it will set it to false to say that it is now allocated. Cycle the free list head around. So remove it from the free list head and put the next one on. And then it will basically shrink the block and put the remaining side. If it's a perfect fit, we'll return. If not, it will take the end of the block and put it back on the free list as a new block. And then return the block there. Good. Right, so I think everything's in place now. I would like to say that is. See if that still works. What's the problem here? So the validation is failing now. We obviously screwed something up in this code. Yep. Our block end index 35 does not reference the correct end block 33. I don't know how I worked that out, but Pass Henry has done it again. How did I work that one out? Right, so I guess we'll go to this code here. 2982. Right, so it goes over every heap, then it goes over every block in the heap. That bookmark physically contiguous memory. So the blocks themselves are linked listed, but the memory they reference is physically contiguous here. And this line here is saying right. So the heap end index is this one, and the one we actually got to in the link list was different. Okay. So why? So it means that the heap block end is not being updated correctly. Or, right, I see. So it must mean that when we no, so when we make a new heap, we're definitely setting these correctly. And the only time they ever get removed or get changed is when the block gets deallocated itself, not the memory, but the block itself gets moved into an unused linked list. Right. Okay. That's interesting. Why are these always... So it already got to 33. Did it ever come across a 35? We don't know. Hmm. Is it a fixed seed? Yeah, it's a fixed seed. So we can keep running that again basically and it'll fire off. The same. Hmm. So, right. I guess let's look at these and see what's up. And why are these IDs instead of indices? They're never going to be null. Ah, it's because we use it for the linked list, maybe. Right. So when we allocate and you want to take the end of the block that's not used and make that a free block. This is when we set up. So you link it back to the previous block and then point to the next one. That's okay. This next one should point back. So if you have a next, it's got to point back. Yeah. So, and then our block with allocate will point to the free block. Yeah, that's right. So this seems correct. When we deallocate, we have, yeah, this will deallocate. Right, I think when we call block dealloc, it will deal with stuff like this. Oh, where is it? Right, block alloc. If you have a next, it will go to the next block and make it point back to our previous one. Same with the previous, make it point to the next, to our next block. Right, and then if this block is the end or the start of the heap, we'll make them point to the next one. Right, that all seems quite okay. I don't know where the problem is then. Yes, that's when you deallocate a block. All right, interesting. Cool, so we keep running it, it's persistent. So I guess what we can do is just print out stuff, which is great. So what I want to do is when we allocate 33, index 33, so invalidate. Right, what should we do? So I'll print out and just say visit and then an ID number. We won't do an ID, we'll do an index because they refer to indices in the error message. Let's try that out. Right, so it's complaining that 35 should be the end, right? But it only really managed to reach 33. But if we see here, I can't see a 35, right? So I think what's happened is 35 got lost, or 35 didn't put 33 as the new correct end index. So why would that be? See, I guess how did 35 get there? That's the question. So we want to say, do another one, and we'll say heap block end index heap whatever block end index is that. So we'll call it heap index. So let's try that out, see what happens. All right, so actually the one that we're working on now is the one that caused it to be set to 35. Excellent. So we should be able to put a breakpoint in here and find out how this happens and why it's not done the linked list properly. So if I go to validate, it's when the index is 33. So we should hit a breakpoint. Okay. So it doesn't allocate. And we find out that, oh, so it does hit this code as we kind of expected, right? Because this was the new code we added and it broke. Interesting. Right, so imagine this index is 30, or this block is 35. 34, eh? Right, then it creates a free block. Yeah, called 35. Okay, so it must be the so when we allocate from a buffer and say if they want a portion of what's available, we'll give them that. So we take the block, we mark it as not being free anymore, and then we change the size to be something smaller. Then we make this a new block and we put that on the free list. So apparently that operation is not being put on at the end of the heap. So if you see, this is block 35. Oh, ID 35. I'm confused. Heap index 0, that's wrong. That was a new heap it came from, right? So the heap index is not being set, that's the issue. Yeah. Alright. Hey there, Pink Waffles, how's it going? Welcome, welcome. Yeah, so we didn't set a heap index on the block. So whenever you get a block, you gotta make sure you set heap index. So I think I was setting that, but I think I missed it here. GPU, VK memory allocate heap index, allocate a heap, and voila. So let's just take a little look around for this. Yes, when we allocate a block, I was doing it. Hey. What is going on? Right, so we are. Now I'm confused. Something is very wrong here. Breakpoint, there we go. Okay. So let's just skip ahead and see the block that we got. And it says heap index 0. That is wrong. So when we try to allocate something and we've run out of memory, we allocate a new heap. Oh. So here's the Vulkan memory allocate function. So this is the block. Heap index 1. Ta-da! So well, that's 34. So it makes it 35 there, and then we do a get. It's not that. We should print out the memory address because that's bizarre. Right, let's run that again. I'm confused. So right, 84D0. D0. So it got changed in that space. Ah, we zeroed the damn block. What a buffoon. Oh. How silly is that? Super silly. So basically the zeroing should be done inside the allocate function. Right here. Wrong place. So when we allocate a block, that's fine. Right. Yeah, we shouldn't zero the block. That's dumb. Completely dumb. Right, this is that reset function that will just resets all the heaps back to a single block with where it's free. Okay, that's good. So, I think the bugs have now been fixed. So if we just run it with a different seed. So in this test function, we just randomly allocates a bunch of stuff. We'll change this seed around a bit, and we'll just try and see if we can find any bugs, any more bugs. But I think that's everything, because this code was already tested quite heavily beforehand. But we obviously just made some improvements to it and made it do something slightly different. So there shouldn't be that many bugs. Right, these things seem to be passing just fine. Yeah, so I think that's pretty good. We're in a good place. Cool. So now I think what we have is a good memory allocator. We've instantiated the memory allocators. So we've got a memory allocator for static buffers, static images, ones that do not change, and they get created when the game boots up. Then we've got these temp buffers and temp images. These guys get created when you have started your recording into a command buffer, and you then go, hey, I want an image at this size, and you can then deallocate it back to the allocator, so you can basically have memory aliasing. You can alias the same memory and write to different points in the frame, and so long as you don't have two shaders right into it at the same time for different purposes or whatever, it'll be fine. And we're gonna have a system built in so we can catch that basically. So you can't after you've put the memory back into the memory allocator, if you try and use it again in a shader, it will assert. So that'd be cool. Speaking of that, I think I buggled that that I didn't quite finish that code last stream. So what I'd like to do is go into gpu.c and literally just do that sort of temp dialog, temp resource, or GPU resource dialog temp. So I think so I mentioned about needing some flag or something. So I want to do some kind of assert. So we want to make sure that it is actually a make sure that the lifetime is temp, right? Can only deallocate temp. We also should only be able to do it when we are recording a command buffer. Cannot deallocate temp resources before frame start is being called. And then we also want to make sure that it's got a flag, and that flag, or maybe not got a flag, which is called is deallocated temp. So not have that, please. And that will basically say, or mean, resource has already been, temp resource has already been deallocated. And we need to make sure we use that whenever we turn it into an ID for shaders. So there's a thing called like resource index, I think, ID index. Yeah, so whenever we do this, gotta be careful. It's when we do the sync code, right? I think that's right. Right, so whenever we do a sync resource, we want to do an assertion. So these are explicit and done manually, but I want to put an assert in to say make sure that it's not deallocated temp. Temp resource cannot be used after it has been deallocated. So that would be super handy. So my concern is when we create a resource now, texture in it, I think it's called. Whoops. I think, right, it's all zero initialized. Yeah, that's good. So at the end of a frame, So frame submit. We go over all the temp resources and deallocate them. Yeah. Right, okay. Then there's a temp memory reset. Perfect. So in the backend, GPU backend, we can do a memory allocator reset. So that'll be GGPU Vulkan memory allocator for temp buffers and temp images. So all that's going to do is you'll have like your arenas or your heaps, and essentially they'll have some some allocations in there, and all you'll do is just basically get rid of the bookkeeping information, but keep the heaps around. Right, so we get rid of all the blocks, but keep the heaps, and make new blocks which span the whole of the heaps. So that will happen there. So that's good. Okay, so now all we have to do is when we allocate so we have a function called backend texture in it. This is called for both of the static and temporary resource creation. It's going to create. So effectively, right, after we create the image, we can get the size the size and align. And then we used to do this sort of VK memory allocate, but now we've got the allocators. And what's great is we have one for static memory and one for temp memory. The temp memory one gets reset. So what we should be able to do is get the allocator based on the lifetime. Maybe what we can do is arrayify it like this. And then we can just do an array index and it should be a lot nicer. Yeah, so these sorts of guys. So now we should be able to just, I guess, so it's like a for range. I0 GPU lifetime. So there's only two lifetimes, right? One's static, one's temp. There'll probably not be any more. Cool. Right, I don't need to do that test anymore. That's good. Glad we found that. So when we reset though, we essentially want to just reset the GPU resource lifetime temp. Like so. Cool. Right, so when we do that sort of texture in it, we can get the memory allocator quite easily. So do the memory requirements after we create the image, and we can work out so GPU VK memory allocator so that'll be the address of GGPU VK memory allocator for an image, and we index that with resource lifetime. So that'd be 0 or 1, 0 meaning static, 1 meaning temp. And then we can basically call our super lovely alloc function and get a block back. So this is going to get us a block. Now, here's the thing. We should store the block in the resource backend. Crap. Move that around. So we should store a pointer to the block. So we've got a device memory. We'll put that in there as well. Memory block. So this is the allocation. Now, yeah, so what we should do is say, right, GPU VK memory block. So here's the block of memory is allocated with mem allocator alloc. That's the public interface. Allocator, then the size comes from that memory requirements. Size, memory requirements, align. Then, so the thing is the block isn't going to give you aligned memory. It's going to give you a block which is big enough so you can self-align it. This is because, yeah, this is just so it's quicker. We waste a bit of memory just by over allocating, basically, and it makes the bookkeeping a lot more simple. And there's no real search for a block. Well, there is a bit of a search, but the search is all contiguous in memory. So we try and find a bucket, and we search over the buckets to find a free list item, and then that first block that you get from the bucket is guaranteed to fit your allocation in. So what we need to do is take that sort of start index and self-align it. So that memory offset here. So I guess we'll store it in the actual. So we'll say core in round up align. We'll take in the block start and we'll round up to the alignment of memory requirements. Now it's probably a good idea to store this inside the resource. Hey, Devastated. How you doing, sir? Welcome. So it's probably a good idea to store that sort of memory offset in here. I don't know when we'll actually need it though, to be honest, so maybe we won't store it in there, because there's just no, unless we need it, don't store it in there. I think there is some memory API that does ask for it, but I don't remember anymore what that is. So this will allocate a block, and then allocate the image's memory, get the new alignment, bind the memory to the image, and that memory offset, yep, we still need that, and then it creates the view. So realistically, ggpu dot, is it like backend resource backend, right? Memory block equal block. Yeah, simple as that. Yeah, so I think that's good. So that's just gonna create the image view and done. Good. So what I'd like to do, so maybe right, we just do this, since it's not used that much. The compiler should optimize that just fine. What I'd like to do now is copy that and put it in the buffer code with the buffer version. So the buffer is going to do the same thing where it allocates the memory. Instead we've got this, allocate the buffer's memory. Get rid of the actual allocate function now that we've got our own allocator. So there should be less of those Vulkan allocators that happen. which will be quite nice. And then what else? Bind the buffer's memory. Yep. All good. Right. So this means that the static allocator is now going to use our new memory allocator. So hopefully this works. The tests works, so hopefully this works. I'm doing good. How am I? Or how are you? But for me, that's good to hear. Good to hear. Yeah, I'm doing good. Just a little bit tired. I went to a work party on Friday. And came back home at like 12, and I was up at 6:30. So yeah, but didn't quite get a chance to recover. But it was a good time. Lots of talking, lots of chatting. But yeah, just the drive was long. Yeah, doing good other than that. Yeah. How's the new house going? You know what? I went to they put us in a hotel. So I stayed over on Thursday. Yeah, I stayed over on Thursday. So I got up at 6:20 on Friday morning, and then I went to the gym that they had there. And typically at home, I just lift some weights. I'm on about 15 kgs right now. So I just, did do all sorts with those 15 kgs of weights, basically my whole body. So I go to the gym and they've got the machines there, and I'm trying those out, and I'm in there for like an hour and a half, and I work out, and I find out I actually quite enjoyed the machines. I've not really used them, I would say, properly. I think when I tried them out before, I didn't really understand it, but when I used it this time, I was really sort of into it, and it was great. So yeah, although I'm still too lazy to go to an actual gym, so it prompted me to think like I should probably save for like a summer house and get some like machines in my back garden, basically, because I've not got room in the house. But I think that'd be pretty cool. I think that's one of the things I'm gonna aspire to achieve is machines are mostly for isolation. Yeah. Oh, you mean to work on a very individual part of your body? You'd have to get enough machines. This is the issue. But it was great though. Yeah. Oh yeah, I went to church today. Yeah, I was at church today. It's been good. I've mostly unpacked everything now. Awesome. Fantastic. Yeah, I do see your point. I didn't manage to exercise my neck that day because I did that. But yeah, I think I would still have some weights on the side. But yeah. And the machines they had there didn't quite do every part of the body either, that's right. But yeah. I'm in UK, right? It's Anglican. No, it's a Protestant church. But yeah, it's kind of I go to it's not it's not a Church of England church. Yeah, I go every Sunday and Wednesday. Yeah. If you don't want to do a lot of put a thought into it, you should make it a routine by going there same time each session. Same time though, right? I see. Yeah, a bit like how I stream, right? Same time, get on it, do it. Yeah, make it a habit. That's true. Yeah, I already have that sort of habit in place for working out at home. But the best thing about working out at home is I can do it with my family around, and I don't have to get in the car, travel for like 15 minutes and stress out about driving on the road and then come back again and have to try and do it all in a set period of time. Whereas if I work out from home, I can sort of, yeah, just a lot easier typically. But yeah, I'm thinking about getting some machines at some point. I think what would be a good idea, because I think my wife wants to go. She's got a gym membership and she likes going, but she hasn't been going for a while since we had the baby. And she's thinking about dropping it, but she likes the idea of the treadmill and the I forgot what it's called. There's another one, so maybe we could start there at least. Right, I want to run this program. If it crashes and burns my computer down, I'll be back, but it should be alright. So the static resources are now using the new memory allocator, and they're sharing the same heaps. We could print out some code, maybe. That'd be interesting. Print allocated blah to blah. Block start to block start plus size. Something like that. See what happens. Let's see all the allocations go. Maybe we should also put a heap number in there as well. Block heap index. That'll do. Right. Hopefully it doesn't crash the stream. Let's go. Alright, it doesn't compile now. Yeah. This constant needs to match the size, so I've made it 40. So effectively, like, the backends are not exposed into the outside the backend area. So essentially, it's just like an opaque bit of memory for the backend data, and it's here, sits after the structure. So it means when I make my poor allocator, I can, I can have arrays of these structures still without doing some extra maths, which makes the elements bigger than they actually are. So now it just actually has the memory inside the structure, but then it gets casted into the backend one. Right, let's go again. Right, validation error. What's going on? Oh, memory's a null handle. Oh, I didn't set up right, of course. We need a way to get the heap memory. Okay, so the way we do that, we need a new public function. So if you have the pointer to the block, it would be a bit of an indirection, maybe. How often do we do the device memory thing? Only when we bind, is it? Only when we bind or create a heap. Sorry, a view, a texture view. Yeah, that's correct. So actually what I'm going to do is, oh, shoot. I'm going to undo this, make it size 32. Then what I'm going to do is remove this device memory thing and make it so you can get a function which will, from a memory block, give you a heap back. Because it does cost a bit to get it. You know, it's an extra level of indirection, but we do it very rarely that you might as well do it that way. So there'd be a bit of public API where you can basically get that device memory back. So GPU VK memory allocator block device memory. You don't really use the heap or get access to the heaps. So you get the heap first. Heap index. Oh, I need the allocator, whoops. Okay, so when you got yourself a heap, you simply just return that device memory like that. Cool. So now when we actually do a allocator alloc, you want to make sure that you set, right, we get the VK device memory. Resource backend memory block. Like that. Cool. There we go. So hopefully that works. Oh. I've not got the debug on, but maybe. Allocator pointer. Right, hopefully that works. Right, so the aliased. Shoot. That's a big problem. We don't know what. Oh no, we can work out the allocator. Yeah, that's not hard. Right, so it's for an image. This is for a buffer. We should have replaced that image with buffer. Right, so you get the allocator. Then you can use this function here. Aliased resource backend memory block. Oh, wait a minute. You just need to copy the memory block over, but it never gets freed back. Right, there's something else as well. We do not want to, if we have a temporary resource, which is a texture view, we never want to free that memory. Yeah, so I think we can block that in gpu.c. So when we got that deallocate temp, resource, right, how do we know if it's a view? Is it the resource type? Right, an alp. Flag, nothing to do with if it is a view. Great, there's nothing to, alias, that's it. Right, so the alias resource ID, that has to be 0. Cannot deallocate a temp resource view, views memory. Perfect. Right, so let's try that. Hopefully that runs. Cool. Right, so that's using the new allocator. We actually got more than one heap. So it's hard to tell what is an image, what is a buffer. But essentially, these are probably a mix between images and buffers. Oh no, all of them are, right? This is a heap index. But what you'll find is, yeah, this is allocated from 0 to something else, 0 to something else. So this one's maybe a buffer or an image, and this is this is buffer or an image, and this is the other type of resource. So yeah, one of them ends up getting a heap, 3 and 4 basically. But yeah, so we're able to share the same allocation there, which should be a bit better for performance when we boot up at least. But at least we're using that then. Let's just go around the scene and just, this glitch was here anyway. But you're able to open up the texture viewer and look at screenshots still and see the depth texture, I guess. Yeah, so everything's working as we expect. Oh yeah, it's just so close that it's... Alright, that's cool. Anyway. Rightio. So next thing to do is actually start using those temporary sources. So is everything hooked up now? So the back end will use the temporary heap allocator. We've got the reset code in, we've got the initialization code in. I do think it is in place. The only problem is when we start using these temp allocators is we will not be able to use them in the texture view, and that's something we need to fix, I think. Because I think the current code, when you see the texture viewer, it will when it displays all the entries, I think it just goes over all of the resource IDs or something like this. I think we'll have to find out. But yeah, let's just try and look at graphics, and let's try and find something that gets some texture, and we'll just get it to create a new. Where's one where it's using that sort of temp display width? Here we go. So this texture here. This is a prime example of one that is going to change every frame. It encodes the depth into it. So we literally move that out and go to frame start. So after frame start, let's just instantiate this depth texture. So rather than doing static, we just say temp. So I guess allocated right here. At runtime, we can pass in a different size for the texture. And then we can free it as well manually and then recycle the memory. But this texture is used up until the end of the frame. So yeah, there's no point like freeing it back just yet. We don't really have any sort of post-processing stuff, but it should, yeah, we'll see how long anyway. So let me remove that. Where's that print? Let's get rid of that. Well, maybe you can see every frame. It will just print out the same one every frame probably. So let's run that and see how it goes. Right, so we've got a crash. So this is because when we do a frame submit, the pointer that we pass in is outside the object pool. Okay. So it seems like we maybe got the allocation here. This seems like it here. Because it's on the temp image allocator, and it's done it from heap 0. But it's when we tried to free the resource IDs back into the pool for the temp ones, it kind of failed. So that's in gpu.c submit. So right at the end, well, oh, let's start. Here we go, submit. So it's a reverse for loop. So which line fails? This line here. So what happens is this goes out of bounds. Now, why does this not fail? All right, just checks the All right, let's take these and put them in that is allocated thing. Right, let's get some assertions. So make sure the object pool is initialized. If the index is outside of the capacity, that's a problem. So make sure the index is less than capacity. Yeah. Right, so we run that, should give us the same error, but in the different function. No. That's bizarre. Alright, let's put a breakpoint in here. Right, so the index then is 57. The temp resource end index, so that should be 1 plus the last index is 58. So this seems like a correct index then. Right, so this get ID, has this been wrong the whole time? No, the index, I think my... Oh, okay. Yeah. So the index is... Huh. Oh my days. Somebody forgot a multiply by a multiply. Right, so what I didn't do here is multiply this capacity by the entry size. So this is just dealing with like a void pointer. So entries is just an array of entries in the object pool, and we just pool allocate the individual entries out. So just trying to make a pointer which goes to the element after the end of the entries array, and I was just adding the number of bytes. Wrong. It needs to be multiplied by the entry size. Cool. So that should have worked out okay. Right. Hopefully this works. Right, we hit the breakpoint again. I didn't save that file. Right, this error is doing a get in the texture viewer dispatch copy. Right, so we might have to fix some of this texture viewer stuff now, we'll see. So when we start a frame, why is that one failing? Attempting to get 25, but 25 is not allocated. Huh? Right, let's put a breakpoint in here and just analyze what it's doing when it's getting rid of these temp resources. Did I go too far? GPU temp resources start next 57. Right, so it should only do one. Okay. So it just deallocates one slot. And that's not 25. Let's double check that. Resource. Forgot how many bits it is now. Well, let's just get the first 10 bits or 12 bits. $57, perfect. So it's only going to deallocate that one, that's fine. Right, so we go back around to a frame start. How do we do that? Right, since I frame start, right, texture viewer. Interesting. So the texture viewer one's not allocated anymore? Was that the problem? No. Oh, what's this in the selected tab? Let's check the first 12 bits. 25. So we had 57 resources that we allocated. How did 25 get freed? Well, that's not there now, is it? Right, it's interesting. So maybe right, I don't think I've tested the deallocate function yet. No, I must have in the past. Maybe I've introduced a new bug somewhere since I've last used it. Right. So it's something to do with that bit set. So when we do a deallocate, so I guess I could put a breakpoint in there again, actually. So when we do object pool deallocate, I think when we you're doing an unset 57. So if I print out what is object pool entry is allocated bit set, so you're looking for 20 25, wasn't it? So we shift right 25 and then and 1. What do you get? 1. It's set. So when we go into this unset index, oh, did somebody simply not cut? Damn it. I didn't cast that 1 to a 64 because that's going to shift it and then it will underflow or something like that. I think that's the issue. This is one of the pain points of C programming. Absolute classic. It is. This one is like an absolute bugger. But when you know it, you know how to keep an eye out for it. But yeah. Bananas. Bananas. Right, hopefully that's alright now. Fingers crossed. I'd like to think that's the fix. Alright, here we go. Right, attempting to get entry 57, but it's not allocated. This one's better. 57 is that temp resource. So the next frame... No? I don't know. Yeah, I think it would have done... Yeah, so it already would have allocated it. Right, let me do another print and go... Oh, what is that? Is this Windows or something? Right. Let's just do that. Let's print out a frame mount. Yeah, so we've already done one frame. The next frame, when it came around, for some reason, we're maybe using it before it got allocated, but it's done at frame start, so I don't know. So 1520 inside graphics. So 15. Wait, is it 1510? 1520. Look at the taskbar. It's leaker than Windows. You mean like Windows 10? Yeah, I quite like KDE. It's pretty cool, pretty snappy. You know, I've got Windows 11 on this PC as well on a different NVMe drive. And, you know, I think someone was saying, you know, Windows never has like rounded corners or something like this. But yeah, Windows 11 has rounded corners. It's even got that sort of shadow. And all the icons are in the middle. Like Mac. They really did kind of try and make it like Mac in a way. In certain aspects. And then they sort of like added this sort of another layer on top of Windows. But, you know, all the old stuff is still there if you just click far enough. It's interesting. Yeah, it's bizarre. Right, the problem clearly is here. We're not reallocating the same resource ID back out, which is a bugger. So we should be. Oh, what the hell is this? I did this in the upload code. Record the first command buffer to upload all the static initialized data. Ugh. What a bugger. So we shouldn't be doing that. Shouldn't be doing it there. Do it here. Alright, so I did it in the wrong place. Whoops. Yeah, so when in my sort of graphics in it, I basically do a frame start, do a bunch of uploads, and then do a frame end. But yeah, in my render frame function, I also have this frame start, frame end, because that's called every frame. And I put this depth texture in the wrong place. So yeah, now we're creating a depth texture every frame. And let's see how that goes. Let's go. Would you look at that? Temporary resources. So let's look at the depth texture, see if it shows up in the... Yes, here's the memory gets allocated every frame. And if I open up F9, does the depth texture show up? No, it doesn't. See, this is the problem with it. It doesn't show up. So we've got to get it in here and be able to view it. And then we can just move everything over. And yeah. Then we can start work on swap chain resizing. And yeah, should be pretty amazing. Resizing is work. Too bad they didn't add an option to remove rounded corners. They didn't add an option? Is that not in the registry somewhere? There's a GitHub link somewhere. You'd expect it to be in the yeah, registry. Oh no, it's a tiny app. I thought it was a registry name and did look at it. Right, double click it. Okay, I guess it patches Explorer somehow. Oh. Funny. Classic. Hi all. Not all stuff is back in 11. You can't see the latest software update anymore from other programs. Other programs than Microsoft, huh? Right. That's strange they took away features. Yeah. I put Windows 11 on my PC because it was just the latest one, and I don't really, use Windows all the time. I just use it to run this application and see if it works. And keep it working, basically. But yeah. I remember when they did that Windows 8 thing, and then they had the Windows Phone, and it was all using that sort of Metro thing. There's been a lot of UIs that Microsoft have made over the past, I don't know, 14 years. They've had yeah, I think 3 different UIs to replace WinForms. There's been a lot. It's kind of crazy. Yeah, so for those who don't know, I have a texture viewer. It's built into the GPU layer for some reason. It probably would be better off to built into the graphics layer. But it does kind of go into the internals of the GPU, so this is why I did it this way. So let me figure out. It's got all the immediate mode UI code in here. So yeah, GPU texture viewer UI, and this is going to go over all the resources and display them basically. So what we need to do, so I think when we do this sort of like UI thing, so I might have to just take a list. Yeah, so UI frame end. So it's done before the GPU frame even starts. And even if I moved this sort of stuff later, there still could be some places where we make temporary resources at the end of the frame or something like this. So ultimately, this is fine to stay here. I think what we need to do in the internals of the GPU layer is build up a new list of resources which just keeps the information that we need. So it's just a new structure basically, just with all of the data part of the resource. Oh, it's just all the textures. Yeah, it's a texture viewer. So if we take a look at the resource in here, resource. Right, what do we do? We get the debug name, we get like the sample format, the dimensions, and the MIP levels. So I think we just take, and maybe the resource type, stuff like that, right? You know, so I think we just need a new structure, and maybe the alias as well. Or sorry, if it's an alias, we skip it. Cool. Right, it should be quite easy. So internally, inside the GPU, all we need is another one of these, and we'll just call it a texture something. Texture info. Right, it's not something that we're trying to actually use. So we have the resource type. We could keep the lifetime in there. I don't think we need any flags. Well, you'll need some of the flags to say if you want to flip it or not. I wonder where that happens. No, that happens when we do the copy. So debug name, and then you just need all these texture ones basically. Oh, just like that, yeah. So I reckon if we just dump an array of these every frame, and then we have a frame of delay before they get displayed in the UI, it should be all right. I reckon that ought to be good enough then. So we'll probably have something called a core defined stack. So texture info, core stack, texture infos. So every time we make a new texture, we'll just put it on there. So that'll be in gpu.c, texture init. Yeah, so all we need to do is just say GPU texture info, core stack push, ggpu. Now I think we actually need to instantiate this as well. I did forget to do that. So we instantiate this with the static allocator and the number of resources as the capacity. Just over allocate there, that like that. Yeah, then we just fill it all in. So we want the type. So it's probably just all this stuff here. Like that. Pretty cool. Now we just need a way to clear this array. So so when you call a frame start, no. Yeah, when you call frame start, you clear it. So we'll clear all the texture infos. And then inside the we might need to record a resource ID, maybe not though. We can maybe get by the name hash. Yeah. So yeah, we'll just do a for long string compare, I guess. All right. So in the resource viewer UI, we just need to now replace where we use that sort of GPU resource. We go over all the resources and display a list. Just got to be very careful here what we do here. So we'll probably say the selected tab. So there's maybe not a selected resource ID, instead it's probably a selected name or something. A name hash might be better. Yeah, let's do a name hash. I think it disables them if it found no graphics drivers. Interesting. Yeah, you would think they would do that. Yeah, so we're going to use a name hash instead now. So when we create these resource, we'll call it a name hash. Whenever we set these, so it'd be something like core string hash. And I think we do like a core string from a C string. So we just do stuff like this. It should be easy just to pass the name hash around rather than a pointer to the debug name. It'd be a lot safer that way. Mainly. Yeah, these should probably be done a lot better. These are just some built-in buffers and things that AO. Buffer initialize, texture initialize. Great. So the name hash in the info. Wait, let's just double check. Oh, texture views never get added to this, but I guess we'll put a name hash in just in case. be useful that way. Right, we're good. So in here as well, we'll also need the name hash. Equals resource name hash. Nice. Right. So in the UI, well, we get this sort of resource. Yeah, I removed that resource ID and replaced it with a name hash instead. So it makes a new tabbed area, goes over all the tabs, checks to see if it has a yeah, if it has a resource, if it doesn't. So I guess I'll just say name hash. Now we need to be able to, so we want to be able to find not find a resource with a name hash, because these resources will not be allocated anymore, but a texture info at this point. So in that internal GPU internal header, we'll need a way to say GPU texture info from name hash. And you probably want to be able to do it for a resource as well. Yeah. Something like that. All right. So I think we're just going to search over all of the yeah, this iterator here, which I'm probably going to have to get rid of in a moment. So go over all the resources using the iterator. It's not the best thing since there's holes in the object pool, right? There's 3 elements, but it works. It's just for debug code anyway. So we say if the resource name hash is equal to name hash, or return resource ID, or just, sorry, the resource. And it will return null. So this other one is do the same sort of thing, but this time it's going to go over all of the infos. So that would be ggpu texture infos. And then we just say if. So I guess we get the texture info as a little pointer. Why people use C++, everyone hate it when there is a C, there's C everyone hate. Huh? Oh, you're just saying everyone hate regardless. Well, people are onto the new aged religion these days, you know? And that is Rust, Zig, Odin, Jai, and they got the new programming religion. It's basically, isn't it? And C is unsafe. C++ is probably unsafe and complicated. But then they just trade it for another complicated thing anyway. But yeah. The fun part is that the rounded corners weren't bad. At the start, literally, you saw black Sorry, were bad at the start. You saw black pixels and artifacts. John Blow implemented rounding corners in 3 hours on stream. Stuck on it, UI editor, and they were way, way better. Yeah, it's just a sign distance fill discard, you know. Not bad. But yeah, it seems like they had... Oh. Yeah, weird. Yeah, so if the name hash is equal to the name hash, and voila. So we've got these nice little functions. We'll use them. Alright. So we find the UI thing again, and we're looking for every usage of resource, because at this point in time, what is all this code? Was this me testing the combo box? Yeah, I added support for a combo box. Okay, let's delete this code. This is me testing out the combo box. I wrote the usage code and then I implemented it, right? Cool. I've gone out now, get out of here. Right, okay. Much clearer now. So, in the texture viewer, we've got tabbed area. We used to search over all the tabs, and if there was a name hash, we got the name. So now how we get the name is we do a texture info from name hash, and we just take the tab's name hash, and then we get the texture info, and voila. Cool. So that's that problem solved. The next one is here. So if we have a tab that's not empty, we are going to see this got the resource ID. But yeah, we just want to get the, again, we just want to fetch the texture info. And then we want to do a split area where the left hand side shows all the lovely properties, right hand side shows the image, and we can zoom in and, you know, look at pixels. So you press the back button, it will set the name hash to 0. Then all of this does resource something. So we look for this and replace it all with info that kind of. So now we've got this info which lasts longer than a resource. A resource will a resource may not be allocated yet when the texture viewer UI code runs. So yeah, all the temp resource ones will not be allocated yet. So we have this info array which will get allocated, kept around for the next frame, and when the texture viewer UI code runs, the info has all of the properties in there that we need to display. Crap, what did I just change? Right, that's good, that's all the... Nice. Cool. There's still quite a lot of little things in here. Right, so resource. So it's a 3D texture, you use the layer or something like this, I don't know. Cool, so this is when we don't have any tab selected that has a resource. Instead we've got a tab which has no resource. So what we need to do is display a list of all the resources. So here we used to go for the whole object pool, but again, not all resources are actually allocated right now. So what we do instead is we will do a loop over all of the infos, texture infos, and we'll just do a GPU texture info data. All right. So here we're simply, if we get rid of all that stuff there. Wait, this was saying if it is the texture viewer copy resource ID. Interesting. Did we, yeah, I want to be careful here. So if it's not a texture, yeah, if it's not an alias. Alias is not put into here anyway. What's the name of this? Yeah, so I called it this, right? Yeah, we need a special name hash. How do I do that? I need to run the code. Maybe we'll put it in another little program for now and run that because it's easier. Call string hash. Printf hash hexadecimal, please. All right. So if we run the encoder system, there we go. There's our hash. So we'll put that as a constant somewhere. So cool. So we'll call this the GPU texture viewer copy name hash. All right. So when we don't have anything to view, we go over all of the resource infos, but here's the old code where it went over all the resources and it checked. So we go if info name hash is equal to that copy, we're going to continue. So the texture viewer copy, or the way the texture viewer works, is when we take a list of all the writes that texture had. So we wrote to a texture, we'll be like, hey, this dispatch wrote to this texture. It drew a little square. So we mark that down and we have a bit of history that you're allowed to select. So there's 2 times when it got written to, one it wrote that and one it wrote this, on different dispatches. Oh, why am I saying this? Yeah, so the way it works is if you click on this one, before it drew this block here, it would take a whole copy and copy that texture to the temporary, well, this could actually become a temporary resource, but yeah, it's called the texture viewer copy texture. So we just copy it to here, and then this is the one that actually gets viewed in the UI, right? So it copies it at that point in time. Yeah. So we don't want to have this one actually be inside the list of textures to view because there's no point. So all that's good. And then we say if the filter has got nothing in it, accept it. If not, fuzzy filter it based on the debug name, and then filter texture IDs. So this, I would like to then call it the texture name hashes. So info name hash, cool. Right, so next thing is that the we then make the list. So we go over all the list items that can be scrolled, and we're essentially just getting out that name hash. And we'll get the texture info. Texture info from name hash. Right. So we make a button. If the button gets clicked, we put the name hash in the tab to say it's the selected name hash. Cool. And then the viewer mode. Interesting. So we want to get the default view mode based on the format of the texture. So I guess this was taking a name hash. Nah. Wait, where is this used? Yeah, we'll just pass in the info. Does the C++ RTTI features even work, or is it a myth? I get really confused when people say RTTI. Is it like all the destructor stuff and all that, isn't it? And like, you know. Runtime type information, I believe. Yeah, but is it runtime type information? I thought because you don't have runtime type information. Hey, unlike Windows, how's it going? Thank you so much for the raid. How did the stream go, by the way? But yeah, we were just speaking about Windows actually, and Windows 11, and there's rounded corners. Right, make a new tab. We're just fixing up our texture viewer. Yeah, just fixing up the good old texture viewer. Because it's broken. We've added a new kind of resource allocation, and it doesn't work. It doesn't display our temporary resources. Hello, fellow handmade person. Cool, cool. Nice. What stuff was you working on? Yeah, they have that decal type, isn't it? Yeah, type of, I don't know. Yeah, it's bizarre. It's probably, yeah, it's definitely probably really overcomplicated and weird. I've never seen the runtime type information in C++. Awesome. Oh yeah, the destructive called RAI, yeah. See, I kindly like take this stuff out of my brain and dump it in the bin. I did some like standard map stuff the other day, and I was like, yeah. Oh, I was examining differences between returning a strut and a pointer to a strut in C using Godbot. Nice. Yeah. I've never looked into that. I understand that when you return a strut, it basically makes it a pointer on the strut on the stack, I believe, from understanding, right? If your return is a structure that is more than two scalar elements that fit into registers, from my understanding, something like that. I think there's a bit of an optimization if you've got a small structure that goes on. I think, you know, it probably highly depends on the calling convention. But yeah, tell me your findings, please. Yeah, info. Right. Yeah, I might give you a follow just in case you're streaming after me. Because I'm always looking for people to. I need to follow more people to send people after I finish. So return a strut and make it a pointer in the stack of your strut. Of your. Yeah. So make. Yeah. Yeah, it's as if you are passing a structure into a function. It allocates it on the stack. And then the base pointer, the base stack pointer points to before that or something. Or wait a minute. Yeah, it depends. It's a bit different if you return it. Yeah. But I think there's an optimization where if you do a small structure with two scalar elements, say if you had like two U64s, I think there's an optimization for that. Although I'm not 100% sure. It probably, well no, it definitely depends on the calling convention, that's for sure. Yeah. I might be wrong. That's alright, no worries. Have that good break. Catch you later. Right, what else is going wrong? Right, GPU internal, texture viewer. Select tab. Oh, it's a public function. Hang on a minute. New tab. Equals new tab. Is this something that's done? Oh, so my two screenshot tabs are created here. Interesting. All right, so maybe we keep that as a resource. But then new tab is used. Oh, it ain't. Right, hang on a minute. Right, so I believe it has to be a static resource when you do a new tab. So this is okay. I don't think I'm using a new tab. Oh, how do I make a new tab when you press the plus button? What the hell is going on there? Alright, new tab. Tab init. Zero the tab. Oh, but it's got pointed to the tabs count, so it'll modify that right in the UI. Got it. Right, okay. So resource get res ID, then resource name hash, get the info name hash, cool. Right, that'll do it. So what else is problematic about this? Okay, so now we've got to get to how we actually perform the copy. So that stuff I mentioned earlier where we, before we do a dispatch and write to a resource or something like this, or sorry, after we've done a dispatch and written to it, if it's the one that's currently selected, we want to, wait, no. Yeah, this is building up the list. So after you've written to a resource, we put it in a list and keep track of all the times it's been written to, type of thing. Right. Okay, I'm just going to take a quick break and get another drink. And then we'll, wait, Mr. Nodis said something. I think when you're trying to strut, the caller allocates it on the stack and passes pointer to the callee, right? Yeah, that would make sense. Maybe it could know it. Yeah. Yeah, that would make sense. Yeah, the calling conventions could be made far better these days, but they're still stuck in the sort of old way of doing things. Right. Just get that drink of water and we'll get back to doing this PRP. Alright, welcome back everybody. So had some good news. I have my wife playing loud music downstairs and I'm like, what's going on? And she's dancing around, praising the Lord because she's found out that she's pregnant. So, we had that in the past, but there was unfortunately a miscarriage. So, yeah, hopefully this one is it. She get a sibling for the boy. But second time. She, so now we've got 8 months. 8 months to get the this list done. Yeah, before I take a break, where is it? Is that game tech plan? The plan. Yeah, this plan has now got an actual physical date now to be finished by all the editors. Probably about 8 months, and then I'll be taking probably a short break, a couple of weeks or something. Yeah, second one on the way sometime. Very, very early though. We just found out some news. But yeah, so that's great. Been wanting a sibling for this one. It's going to be a lot of work. I'm hoping my current one, Zeke, walks around soon and will be less, I know, a bit more with it, and but very hands-on with 2 children. You don't need calling conventions if you have one translation unit with no libraries. Amazing. Yeah, but how can one program without libraries these days? But yeah, that's true. The compiler can do whatever it wants with all the static stuff. Ideally. Thank you. Yeah, it's gonna be good. Looking forward to it. It's gonna be amazing. I'm in this mindset where I cannot imagine what this baby is gonna be like. But it's gonna be awesome, I imagine. Yeah. Because as soon as like the first one came out, I sort of put him on me, and you feel just sort of this sort of warmness in your heart. Just is so, it's really nice. I did not realize how much how like obsessed and in love you are with your child, as soon as they come out. But yeah, exciting times ahead. Command finalize. Yeah, so here we've done a recording to the command buffer a command, and then we called this with a command name, and we're just building up a list of every time we've written to a particular resource so that the texture viewer can display a list of history and we can click on the history. So instead, we need to get the resource and then get the name hash. Yeah, thank you. So yeah, there's a timeline now, 8 months to get all the material editor, model editor, and a level editor. I think the level editor is not going to be that complete because there's not much stuff I have like lights and, you know, I just have models. But yeah, that's my aim, and then we get back to rendering whenever I come back from the little break when the baby is delivered. And we do some good rendering, like, you know, we can at least build some kind of scene with the model editor and the level editor, put a little scene together, do lighting and all this stuff after the baby comes. So it's a nice little sort of like before and after, which is great. Should be quite nice. Should be pretty fun. So the selected tab name hash. Yeah, so if the resource that so we go over the resources that we synced on, and we simply say if the tab, the current selected tab has this resource and it's been written to, we get the command name and written by command names, we push them on. Yeah, it's a bit sketchy with these pointers, to be honest. What's going on here? Oh yeah, because it's just a shader name or static strings. Perfect. That'll do. And then we're simply just comparing the strings. Right, and if you've got a duplicate shader name, because you might use the same shader to write the same resource, you basically have a command invocation, and you just right, what is this saying? Okay. So we've got this cursor, and we increment the cursor every time we come across the command name that equals. And the current tab that's selected is a command invocation. So we've clicked on the third one, the third sort of command with the same name. We'll know about it, and we'll only do the copy if it is the same name and is the third one, as an example. Right, so after you've looked over all those resources, if the do texture copy is set, we call texture viewer dispatch copy. So this is the thing that actually does the copy to that copy texture. So, right. So dispatch copy, if the name hash is nothing, will return. So this is where the resource is going to exist at this point in time, because you've actually recording the frame. So this is where we can use that resource from name hash, and we'll do tab name hash, and that should be all right. Yeah, then we do a GPU resource ID, core object pool get ID, GPU resource. So from a pointer to an ID. Cool. And that gets you an index, so just hands the bits off basically. And that's what we use in the binderless resources, right? We just use that same index. Then it does some synchronization, and voila. Cool. View offset. Crap. So I think I've got to copy some of these flags. Name hash. So this is to say global view offset scale. Yes, so for the screenshot images, I want to be able to have two screenshots open that I can switch between. And when we sort of drag the, when you zoom in and offset the actual texture that you're viewing, I want it to stay in sync. So there's this sort of global view offset scale. And when we create the screenshot textures, those flip that flag on. So they will use the global offset instead of using the actual per tab offset, basically. So yeah, that's all this is doing here. Texture info from name hash. So I think I've got to get the texture info to take the yeah, it's got to get the flags in there now. Whoops. Somebody deleted those. What am I doing? Sorry, I'm being dumb. Yeah, but the flag is set afterwards. This ain't good. Right. Yeah, this really isn't good. It's set it's set after. Oh, hang on a minute. Oh, no, I've got an idea. Yeah, I've got an idea. This is fine. We'll do it in a bit. I'll correct it in just a sec. Okay. Is that all the... Okay, that's all the compile errors. So, the current issue with the way I've decided to do it, so it's nearly there, is that in texture initialize, right, it's adding to this array and it gets cleared every frame. So only the temporary resources are going to show up in the texture viewer with this code. Incredibly bad. So what we probably need to do is every time a resource tries to get used, maybe, we try and add it, we deduplicate, insert, we do it, you know, we try only add it if it hasn't already been added. Then you'll keep searching over this array. It's quite silly doing that. The other way we could do it is at the frame start, we go over all the static resources and just add all of them in. But I think some of the issues is with these flags, you see, these resource flags, is some of these resource flags actually get changed with an extra thing that gets called. So if I do a temporary resource initialize, and it will put the info on the array, and then I call this function afterwards, the one in the info will not be the latest flag. So it only really matters for the global offset one, but I guess what we can do, I guess that doesn't matter. All right. So what I'm going to do is in texture in it, I'm gonna say if lifetime is equal to temp, then do this. Then what we need to do when we start a new frame is we need to go over all of the resources that exist. That are not the temporary ones. They're all the static ones. I need something like this. But not reverse for loop, just a standard one. All right. So this we want to say add all static textures to texture info. So make sure it's allocated. No. Yeah, if it's not allocated, skip it. It should be. Yeah, no, will always be allocated. We don't have holes in these, actually. Get the resource. It must be static. Then resource texture dot. All right. Cool. So that should fix it now. So I think, right, that should be the texture viewer up and running with temporary resources and static resources. Oh, so let's give it a go. Fingers crossed. All right, 1406, we'll see. Right, info is null. So this is because what? Right. Right, interesting. Well, this sucks. What do you need? You just need the type and then the sample format. So why are we not just passing that in? Resource type and the sample format. All right, let's do that. That'll fix that. All right. Cool. So in this case, we don't need the info. Resource type and then resource texture sample format. Cool. What else? Info type, info sample format. Right, let's give that a go now, see what happens. So I found a hole in the array for some reason. Right, so it did the first frame. The first frame didn't have any temp resources at the start, but then the next frame, it would have at least made one temp resource. So we go to frame start. I think I use the count, isn't it? Yeah. So I want to do all the way up until temp resources start index. That's it. That should do it. And then add all those texture infos for the static resources. Cool. So what's happening now is we've got a scene that's being rendered where we've got one texture which holds the depth information per pixel. It's been allocated per frame, and it can change size in theory, right? But yes, the allocate's been cleared every frame, and it gets allocated every frame from that allocator. The textures which are fixed size and buffers which are fixed size, which is everything else at the moment, those have been allocated using the custom allocator, and that allocates fine as well. So if we press the F9 key, we can open up the texture viewer. The screenshot is wrong. And so is the screenshot as well. That's painfully wrong. Yeah. Right. So that is very bizarre. I'm viewing. Why those textures like that? So if you look at the screenshots that would have got uploaded, it's in the screenshot 1. So every time we take a screenshot, it saves it with a date timestamp, but it also saves it as a texture 0 or texture 1. These are the screenshots. So this is what should be displayed. It's the scene, but with the color picker, like that basically, or like this. So we do kind of see it show up. Just press the F9 key again and have a look. So it seems like we can see it. It's very faint though, right? Oh, it starts off as being an int. Interesting. Right. Nice. Right, so that mode, that viewer mode that we was looking at, clearly not right. But yeah, so this is looking okay. Property info. Yeah, this is not really themed correctly. This should be, I don't know what's happened with that. Anyway, yeah, that view mode is just way wrong. Viewer? Ah, so view mode, good. Right. The storage format. That's why. Okay, so that one's going to get fixed. Cool. So yeah, if you remember when I said there was that global offset thing, see if I move this texture around, I can then go to another one and it keeps it in the exact same place. Only for these screenshot textures because they've got that flag, a special flag on. But yeah, the other ones will be able to be offset and scaled and it remembers them as individual tabs. So let's open up a new tab and see it crash again. This is a different problem. So 1377. When we do a button, we dereference info and it's not got anything. So why? Interesting. Right, so let's put a breakpoint down. So we should have got some Yeah, we would have found some textures basically. And so let's put a breakpoint in here. So we're trying to display a list of textures. We first filter based on the text box filter, fuzzy searched, fuzzy filtered. Then we make a list and we put a button down for every element, every texture that we want to possibly view. Just run it in the debugger. So press a new tab. Right, so name hash is that. And when we search, it finds one. Okay. That's okay. Did it just break? I don't know what happened there, screw it. Right, so something happens here. So really annoying that. Right. Let's see what happens here. Right, so there's two. Huh. So it seems to be a valid. Well, it seems to be a pointer. It looks quite kind of valid. It's a little bit after maybe. Maybe goes a little bit after the array, but I would expect that to not segfault though. It happens on this line. So let's try it again with debug name. So this is another pointer. So let's see what happens on the second one. Nil. Good old nil. Right, so you can see the problem. The debug name is actually set to nothing. Why? Well, it might be an intrinsic. Yeah, it's probably an intrinsic. Yeah. So we always need a debug name now. So when we do like a texture in it or something like this, we need to ensure you have a debug name. Right, so you don't technically you don't actually need it for buffers, but yet, but we'll just require it anyway. Now my issue is also with we've got a bunch of internal function resources that I just make out of the blue. So there's like a surface one here to represent the swap chain surface, globals, indirect args, but they've all got debug names. So I was thinking it was one of those, but maybe it's not. Right, why is it set to null? So we can find that out by going to frame start then, because it's definitely one of the static ones. Well, we can know if it comes from there at least. Yeah, so it comes from there. So what's like the second resource that goes on? Is that like... It might be something like that, isn't it? So what's the index? Maybe it's one of the upload buffers or something. Yeah, it's the second one. It's number 1. So in GPU init, it's quite easy to find. So the surface is the first one, I think. Oh wait, we got the the built-in surface upload buffer. So the upload buffer are these allocated in GPU Vulkan? Yeah, that's another thing as well. We went and added it, even if it was a... right. Based on the type, it's got to be not equal... If it's equal to a... If it's not a texture... Oh, we'll have a call this. Then we continue. And also if it is a view. Yeah, I might do this thing here as well, maybe. So is it equal to that texture view, copy texture? And then the other one was if it is a view. So resource if it has an alias. Right, so how do we get the resource ID? Like that. Cool, so I think I can get rid of that name hash thing then. It doesn't need to exist anymore. Cool, that code is more simple. So that should be it, hopefully. Here we go, F9, new tab, boom. So here's all of the static ones, and then the one that comes last is the temporary resource, which is made every frame. Oh, so that crashes. That because there's an object called get, right, and it doesn't exist yet, so that's interesting. That's probably because it's the initial state, but let's see if the other ones work. So let's go and view let's view the surface. This is the one that we rendered to. So you see like an infinite thing. Here's the history. So first there's the initial state. First we clear it to black. Then we do the ray tracing to render the ellipsoids. They are horrible on jagged edges. We then draw any debug 3D stuff, then 2D stuff, and then the UI. You know, we can do all these sort of things, reinterpret the color. You know, so that all works well. This is correct. That's great. So the one that doesn't work is a temporary one. It doesn't. When it dispatches the copy, it does it a frame start on initial, right? So I think the idea is it doesn't exist yet. So there's the initial state. So what I think we want to do is, so the initial state of the texture, it shouldn't happen at frame start, maybe. Right, this is interesting. So if it's a static texture, yes, it goes here. If it's a temporary texture, you can probably do it when you create the resource. So I think what we should do is say texture viewer initial, I don't know. Or I could just copy paste the code, not gonna lie. Make it a function. Texture viewer, maybe dispatch copy initial, something like that. It would just do this. And then you say if is that right? You want to know if the resource so the problem is up until this point you'll only have a static, this texture info filled with static stuff. So maybe you can just say something like, wait, but this is the selected tab. Texture info from name hash. So I guess you go tab name hash. So you only want to do this if the temporary resource is static in this case, so if it exists. So if it exists, yeah, I think this code will work. So we'll just do this here like that. So this will only end up working for static resources because the temporary ones wouldn't have created the texture info yet for it. So then the other place to put this function call is when you do a texture initialize. When you add the actual texture info here, right? You want to say if the selected tab texture viewer tab name hash is equal to this name hash. Well, the resource would have been created by now. Yeah. Yeah, that works out. Then call this, and this will do the initial copy of the memory, and it'll be all scrambled and horrible, but that makes sense. Right, let's give that a go. Well, it could be scrambled and horrible or be the one from the previous frame if you've got the same allocation range. Cool. Yeah, so there's the initial state. That's when we ray trace. This is when we draw the 3D render into it. This one overwrites the depth. But yeah, that's all right. Yeah, that makes sense. Right, so I think we've got the temp resources working. Cool. I wonder what is... Yeah, so that initial copy... Why is it a problem? You would have just made it. And it might not be in the right state or something. Yeah. Yeah, it's probably kind of crap. Maybe we could have... Yeah, it might not be in the right sort of... Yeah, I'm not sure. Oh well. How do I kill this thing? There we go. Cool. Right, so this seems like temp resources are probably done. What is missing from them? Right, there we go. So yeah, I think we should probably... We could test the deallocation stuff. And make sure it catches if you deallocate too early. That's probably a good test. So the test would be GPU temp or resource dealloc temp. So we deallocate the temporary resource right away. It will cannot use a deallocated temporary resource, right, whenever we try and actually use it in a shader. So that's pretty nice. So this will allow us to recycle the memory back before the end of the frame and allow a new temporary texture to reuse the same memory. Cool. Yeah, so there is a lot of work to be done when it comes to making resizing happen. The next step is to get the swap chain working properly and resize, because right now what we do is we in the Vulkan code base, what's it called, swap chain and friends, that's it. So oh, I might already have it in here. What's going on? Maybe I've already done the swap chain stuff, but it might not be perfect. Right, so this is when we instantiate the GPU side of things. This call is when we start a frame. We wait for 2 frames ago to be finished before we start using its stuff. Let's wait for semaphore. Acquire the next image. If it's suboptimal or out of date, we recreate the swap chain and go around again and try and acquire. So yeah, we wait for device idle. Yeah, there's some things. So there's... I closed the damn tab. There's a GitHub link that we visited on Tuesday, wasn't it? Here we go, this is it. So swap chain recreation, there's like a sample, actually made by Kronos, where it like tells you how to do it the proper way, because there's technically a bunch of different systems interacting with each other. And yeah, should probably read this and try and understand it. Maybe we can try and correct this, but it seems like it's in a good place. We just wait for device idle. Maybe it could be improved, but if it works fine, maybe we can leave it alone for a while. I'll drop the sample in chat. But yeah, it seems like we wait for it, destroy the swap chain and the image views. Right, maybe that... Ooh. Yeah, and then we just create a swap chain, right? And then the fake images. So effectively in my custom shading language, it has a bit of a requirement how it does storage images, and it doesn't quite work with swap chains. So I've had to create a new temporary texture that gets copied at the end of the frame. I'm going to try and work around that at some point, but right now this is where it has to work. Maybe there's a way I can fix it in the future. But it seems like we've already got the resizing there. The problem is that I'm using a bunch of constants now all over the code base. So there's these constants here for temp, display, width and height. There's this many of them. Ignore all these GFX old folders. So there is only this many to solve actually. So they're hard-coded in shaders, they're hard-coded in game logic, or in the game code, so the very little game code that we have, and the editor. And in some operating system stuff as well. Yeah, so if we could get rid of those and move all of the textures to be in temp resources, it should just work. Hopefully. So maybe we could get it done next stream. That'd be interesting. Let's quickly find the resources that are currently using temp display. So this color picker plain texture. So those could be done using the size of they're actually needed to be. That's great. Oh. Yes, that color picker. These color picker ones can be made the exact size that they need to be. So where's the color picker? So this renders the color picker. Color picker plane, color picker slider. So the dimensions are here, right? So I just did this. Oh. Okay, so color picker dims, make the color picker texture temporary one. Then, right, this only needs to go across one dimension. So it's color picker dims Y, so that's the slider. So it only needs to allocate a small portion based on the size of that color picker itself. Cool. Yeah, so no, the problem is it's got to be the resource ID that we use. Crap. The problem is the editor has that color picker resource ID. No, in the UI code. I did a super hacky thing where I reached in and grabbed the resource ID from the graphics system. And it wouldn't have created it yet. Yep. Where the crap has it gone? Color picker. Here we go. Yeah, right here. So the issue with that so this would have to be made like a static ID, which we don't have yet. We don't have this feature. If it was made a static ID, we could just refer to it that way. Yeah, this is a little bit strange. So all of the UI code, whenever it renders an image, it needs a resource ID. And with the new designer temporary resources, the resource IDs are allocated every frame. But the counter bits change, so we can know. Yeah. Yeah, I wonder. Yeah, they would be quite handy to have temporary resources work with the UI. You could probably introduce a level of indirection, right, and do some kind of like name hash or something, and that then gets turned into a resource ID. Because having the resource ID directly is a bit strange in the UI system. Yeah, maybe you refer to it via a name. It gets hashed up, then searched and searched for, but you know, we're not rendering that many images on the screen, so maybe that's the way we get around it. But the problem is this is pushed directly into a buffer, and this buffer gets put onto the GPU, and the GPU just looks directly at it when it renders the UI. So we'll need a patcher. So you'll need to know the word it gets put in on, and then basically patch them later. We glyph to patch. So there is a glyph to patch system, which I guess is going to patch. Yeah, but it's uploaded before the temp resources are even. Damn it. Right, so here's the patching code where it patches the glyphs. So when does that happen? At the UI frame end. Okay. So it seems like, so in the graphics code, when we upload the when we do an upload to a buffer, the UI stuff, right? So we do a, oh shoot. So do a frame end here, then we do a frame start for the GPU. So we record directly into the command buffer. Here we're saying, right, upload. So I guess if we put the upload at the end of the frame, we might be able to put a resource ID in there. Oh, sorry, we might be able to patch these words and then put the correct resource ID in there based on the name hash or something like that. And then yeah, it's weird. I'm not a big fan of using strings though for stuff. So yeah, we might need something. But yeah, so for now, I think the color picker stuff is not going to change for a good while until we solve that problem. We'll just live with it. So the color pickers is going to stay like that, and they'll probably max out at some resolution. Yeah, we'll just have a big resolution for it, just in case. But yeah. Right, so other than that, what else we got? We've got the screenshot textures. They are the max. Yeah, these ones need to probably be we need to have some maximum texture size, basically, that we display to the screen. That replaces that. That's what those two get replaced with. This is some debug drawing code For all of the BVH stuff, we can probably get rid of all that code now, not gonna lie. And this texture that we've been using for the temporary resource, we could swap it out for the actual size of the swap chain image or the surface image. So that'd be pretty cool. Same for this UI rendering stuff. And these screen dimensions here, that can be changed out. Yeah, so it seems like it shouldn't be too bad to do this. Right. Yes, hopefully by next stream we can get that all sorted out. So I'll next be streaming on Tuesday at 7:30 GMT now. And same time on Thursday, and then like 4 hours ago next Sunday. So Tuesday we'll get the swap chain stuff, you know, the whole window resizing for the game, and fix all the problems we have there. And then on Thursday, I'm thinking we can probably, so I have my encoder system working now, so we should be able to move on to the material editor. So this is the first editor that we're actually going to build. We're going to design the data format and get a file actually saving and loading. And then render an ellipsoid. Yeah, render an ellipsoid in the middle of the screen. And have material properties on like the right hand side or something. We probably want to render to a texture and then have that texture like displayed inside the UI system. I wasn't going to do that initially, but I think we're going to do it now. And it's just going to be a very basic property editor for a material. It's not going to have any texturing or painting. I don't think I'm going to do painting, to be honest. But yeah, it's not going to have any texturing. And yeah, this is what we'll be working on probably starting from Thursday. Maybe we'll have a little sneaky one before here called like render to texture, and then you can display that in the UI or something. You know, I think we're going to have to solve that problem with the UI if we're going to have this with that temp resource stuff, because you're going to want to make a temp resource which can change, yeah, between frames. Yeah, so I think we want to probably sort out this on Thursday's stream then, or maybe on Tuesday's stream. But yeah, we'll call it like render display game in UI texture. Do that one stream on that. Yeah, so we'll do that on Thursday, and I guess next Sunday we'll start on this. Awesome. So we've done the color picker widget. Gizmos are done as well. We've not got any mouse feedback. We've done the encoder system now as well. That's ready. It's ready to go. Yeah, it's a good list. So cool. Right, let's find someone to read. But yeah, as a Discord guys, you're gonna come and hang out in the meantime. Thank you for everyone who's supporting me on Twitch or Ko-Fi. Really appreciate it, guys. Yeah, for people who support, get access to the code. I'll put the code we've done now up tonight. But yeah, go check it out. Right, it's ready to arty. I need to follow Artie. I don't want to follow an Artie. So I remember that is on. Right. Let's give him a raid. Let's roll. Right. Have a good start to your weekend, guys. Thank you so much, Clarissa. Appreciate it. Yeah, it's going to be amazing. Cool. Have a good start to work week, guys. I'll see you all Tuesday or Thursday, and maybe I'll catch you guys in the Discord.